who robs things. Okay, just assume that uh, there's a thief, okay, with a bag. Okay, and let's assume he enters our neighbor home. Yes. Okay, so we'll not take our home here. We're entering our neighbor home. Tell me what is the uh, logic that runs behind in thief's mind. He has a bag. What is the logic that he has in his mind? Students. He has a bag. What keeps running in his mind? As he is a thief, he has to rob things. So what will he choose? There might be several items in the home. Which item will he choose? Give me the answer, students. Which items will he choose? Any item or a item which has got more value to him? Whichever he likes, likes, uh, say thief likes some toys. Will he take toys and go? No, definitely he will not. But I think the other answer is correct. Whichever is more valuable. Yes, right? So his main intention will be selecting the item which is more valuable to him. First thing, okay. Suppose say there is one, say one gold item is there. Okay. So besides that, there's one mobile also. Which one will he choose? Definitely, he will leave that mobile. He will choose a gold item because that is more valuable to him. Valuable in sense he has more profit allocated to him. Okay, that's one thing. Second thing is, since he has a bag, what will be in his mind? What will be in his mind? He has to fill the bag such a way that he can easily carry it, okay, without exceeding its capacity. We should not overfill it, right? He has to fill the bag in such a way that he can easily tie and take away and run. He has to run, isn't it? Right? So he has to run. So he will make sure that his bag is full, but not overfull. I hope you are all understanding, right? So his motto will be to select the items which are more valuable and also make sure that when he chooses the items, his bag should not be exceeding the capacity. That concept is only the knapsack problem. So if you understand this, that's more sufficient to know the knapsack problem. Okay. So in the exams, they do ask what is knapsack problem and things. So you should be very careful in specifying. Right. So what is a knapsack problem? As I told you, is something that is given and what are you supposed to find. So definitely given will be now a knapsack. It is nothing but a kind of shoulder bag, right? It is a shoulder bag. Knapsack is a shoulder bag which has some limited weight capacity. Okay. And I also have some items, right? Some items, each having some weight and profit associated with it. Each has some weight and profit, or I can also tell you instead of profit, a value associated with it. So this is the inputs for me. So I have a bag with certain capacity and also I have some items, right? Each having some weight as well as a profit. So I don't have a thief here. So I myself has to put the items into the bag. So the problem states, what is the problem here is, can anybody guess? What is the problem here? Students? Students, what is the problem? What is the problem here? We need to fill the bag with the items such a way that, what are the two conditions that we have? Speak out. What are the two conditions? If you don't speak, it will be difficult. At least tell something. These are all common problems. What is the problem now?
should be limited and profit should be more.
More. Very good. So the problem states here is we should now identify which item should be placed into the knapsack such that the value or the profit obtained by placing the items into the knapsack is maximum, not minimum. Remember, it is maximum. Now you can observe, since I use the term maximum now, the value becomes the profit becomes the objective function. Such that you should know that if I have to place the items into the knapsack, I can only place if it gives me maximum profit, provided there is one more constraint given to me, that is the weight limit of the knapsack should not be exceeded. It should not exceed. Overfilling is not allowed because he is a thief, isn't it? He has to tie that bag and carry, and he has to run. Overfilling, if he does, he will be caught by the people around, isn't it? So that's the reason. So if I have to give you a pictorial representation, you can just see there's a bag here, okay, and it has some capacity. See, you can see it can hold how many kilos? 15 kilos. And you can observe there are certain items available to me. There are some 5 items available to me, each having some weight. So you can see 12 kilos, 1 kilo, 4 kilo, 1 kilo, 2 kilo. And also you can observe there are some profits associated with them. Some dollar I have given, $2, $1, $10, $2, and $4. My intention or my problem here is which should I place such a way that I get maximum profit and such a way that the bag will not be exceeded. The capacity will not be exceeded. Right? That's how I have to just identify. So just looking at this figure, you can have several solutions. You can see I can put 12 kilos once, right? And I can put this 1 kilo, which is having $2. How many, this also, this is only one item. So I can put this, right? So 12 kilo plus 1, 13 kilo, giving me $6, isn't it? And then I can put 2 kilos, giving me $2. That will fit me. 12 plus 2 plus 1, 15. Wherein I get the profit as, how much is it? 4, 2, and 2, $8. That's one solution I'm giving you. Putting this and this and this. Right? Where I get $8. Right? There are other possibilities also to put. You can observe, I can put all these 4. Right? 4, 1, 6, 7, 8, 8 kilos. If I put 8 kilos, all this 4, what is the profit that I get? Could you observe? Though it is less than 15 kilos, what is the profit that I get if I put all these 4 items? Students, what profit will I get? These 4 items, if I put this, and this. 4 items if I put, what is the profit that I get?
$15, ma'am.
$15, right? Though the capacity is not filling the bag, it is only 8 kilos, but I get $15. If I put these 3 items, it will fill the bag, but my dollar will be just $8. Is it? So there are multiple ways of filling the bag wherein I get some profit. All those are feasible solutions, and the optimal one will be one which gives me the more profit or maximum profit. Okay, so now basically in knapsack there are 2 variants I can tell, okay, to be solved. One is fractional knapsack problem. Fractional means items can be selected partially. Usually items we cannot break. Okay, just for the problem, the various problems which here we have is items can be selected partially, right? Which is solved using greedy method. So fractional knapsack problem they call it. Okay, and you have another variant of knapsack. It is 0-1. 0-1 knapsack problem. So this 0-1 knapsack problem is something wherein item should be selected completely, but not partially. So you cannot select the items partially. That's not possible. So items have to be selected completely. And this is solved by using another technique called as dynamic programming. Okay. So in module 3, if you get the question that is with respect to greedy method, module 4 we have dynamic programming that is with respect to 0-1 knapsack problem. So two variants, fractional where the items can be selected partially I can select, and 0-1 as the name only indicates, 0 means do not select, 1 means complete selection. Either you cannot select at all or either you can select completely, right? But not partially. No partial concept in 0-1 knapsack problem, right? Now let us see the fractional knapsack problem. So what does it state, right? So the same thing what I had given. Let us see the problem statement again. Say I have n objects. I do have n objects, okay? Each having some weight and a profit. So I assign the weight to be as a W of I, right? And profit to be as P of I. Okay. For every object, there is a weight associated and there is a profit associated and there is a total capacity, okay, of the knapsack, and the total capacity of the knapsack, I name it as EM. Okay. This is a general syntax followed here, right? So n objects, capacity of knapsack is M, and every object will have a weight and a profit denoted by W and P with respect to every ith object, where I ranges from 1 to n. Okay, so P of I and W of I. Just remember the terminologies, it will be helpful for your problem solving, sorry. And as you all know, I have to fill the knapsack with these objects such that the total value or profit of the objects packed within the knapsack will be maximized. And the other condition you also know, without exceeding the knapsack capacity. So you should not exceed that. Right. So more formally, if I have to tell you, since it is a fractional problem, I use another variable x of I. What is this x of I? X of I is nothing but the fraction of the object I to be included in the knapsack. The fraction. What fraction part you want to include? Right? See, if I am including half means my x of I will be 0.5. If I am including quarter means 0.25. If I am including 3/4 means 0.75, like that. So what is the fraction that you are including? That is denoted by x of I. And what is this x of I ranging from? It will be from 0 to 1. Obviously, 0 means not selected. 1 means complete selection. In between 0 to 1, whatever partial selection can happen. Okay. For every I ranging from 1 to n. Are you understanding? So you should also select or you should also find the values for xi. You should select, you should find what is the maximum profit and what portion of every object is selected, whether it is complete or fraction. If fraction, how much? Or is the object not selected? So you have to find for every I ranging from 1 to n the values of xi. So what are the values of xi? Xi is nothing but the fraction of the object I to be included. Okay. Since we are taking fraction, right? See, the profit also will be fraction. Isn't it? Fraction only I can take. So how do I calculate the profit for every x of I? P of I into x of I. Just a fraction to be selected. So P of I into x of I is to be the profit that has to be made for every fraction of x of I, of the object I, isn't it? Right? Just remember this so that we will do the problem solving easily. Okay. As I told you, the objective here is to fill the objects within the bag such that I obtain maximum profit, right? If you encounter a situation where you cannot include the object completely, you can include partially or fraction. And when you include fraction of the object, as I stated here, fraction of the profit is earned, not complete profit. And how do I get the fraction of the profit? X of I into P of I. Whatever is the fraction, that much fraction of the profit will be included. Now, mathematically, if I have to state the problem, I'll have to maximize summation of P of I into X of I. What is this X of I? X of I denotes the fraction of the ith object selected, and P of I denotes the profit of the ith object. And what is that P of I into X of I denotes? It denotes the profit earned by selecting which object? The ith object. And I should find summation because I should find what are all the objects in the knapsack. So where I ranges from 1 to n. Are you understanding? Where n is the number of objects. Suppose say, if I am selecting the object, say I have 3 objects, I am not selecting the first object. So what is x of 1? If I am not selecting the first object, what is x of 1, students? What will be the value of x of 1? Not selecting means 3 objects are there. First object I am not selecting. So what is x of 1? Speak out. Unmute and talk. What is x of 1 if I am not selecting the first object? Not selecting means what is the value of x of 1, students? What is x of 1? Are you all there? Sanjay?
0, ma'am.
X of 1 will be 0. You are not selecting means x of 1 definitely will be 0. X of 1 into P of 1. Since x of 1 is 0, profit also will become 0. Nothing to do with it. Okay. Suppose say second object you are selecting completely. So what is the value of x of 1? X of 2, sorry. Second object. Completely. Completely, Ranjit. Completely means what is x of 2? Completely means what is the value of x of 2? Students. Someone can answer for me?
1, ma'am.
1. Since it is selecting completely, it will be 1. So x of 2 into P of 2. So what is P of 2? It will be given to you. Just multiply and keep it with you. Plus, say the third object is select half. Partially it is selected. Say it is half. So what is the value of x of 3? As it is selected half, what is the value of x of 3, students?
0.5, ma'am.
5 half will be selected into P of 3. So partially profit only you will consider. You will not consider more profit, right? Full profit you will not consider, right? Such that, as I told you, the weight of the objects. So why this x of I comes to picture? Because you are selecting partially also. That's the reason this x of I comes. Summation of W of I into x of I should be less than or equal to m. What is this m, students? What is this m?
Capacity,
Ma'am,
ma'am.
capacity of the
The capacity of the knapsack. And what is portion of the objects only will be placed. So it should be multiplied again to get the respective weight. Okay. If completely means no problem. X of 1, x of I will be 1. No selection means 0. Partially only it has to matter. What is the profit to be taken partially? What is the weight to be considered partially? Okay. For every object x of I, right? Wherein for every object, that is x of I will be denoted between the values 0 to 1 and I will be between 1 to n. Understood? Okay. So just remember these terminologies so that we can deal with the problem. Okay, so we have a problem to be dealt, followed with the assignment. So carefully look at the problem. The same way you have to solve to get marks. Right. So consider I have three objects whose profits and weights are defined as follows. So n is equal to 3. Capacity of the knapsack is 20 m. Sometimes in your exams they use capital M. So no harm, whatever it is the same, right? And they have given the input like this. P1, P2, P3 is 25, 24, 15. What is this P1, P2, P3 students? What do you think this is? What is this and this? What is this P1, P2, P3 and W1, W2, W3? What are they? What do they represent, students? P1, P2, profits and the weights of all the three objects. And remember, sometimes it is uppercase, sometimes it is lowercase. So it doesn't matter. The way you solve is what it matters. Okay. Now the problem here is to find out some strategy, right? Optimal strategy. Okay, so strategy is applied. You all know greedy method. We have to apply some strategy. So similar to your thief, he has to put some strategy so that he fills the bag to get maximum profit, right? So he would have calculated his strategy. Going inside a home, he knows which portions to be attacked, right? So directly he will go to cupboard, right? Rather than searching in the hall, he will directly enter a room so that he will get good items, isn't it? More profitable items. So some strategy we have to apply. So any greedy problem you take, some strategy will be there so that you can select the inputs according to that strategy and solve the problem in stages. Some strategy will be applied. So we'll see what are those strategies now. Now the various greedy strategies for this problem, that is for knapsack problem. So we have three strategies. Okay, let us see the strategies one by one. Why is this strategy used? Strategies are used just to select the inputs, right? In such a way that it gives me good profit or maximum profit, right? What is that strategy that we apply, right? Suppose before I go for the strategy, you have to write this table first. So we know that n is equal to 3. So your problem solving starts from this slide. M equals to 10. You have to list the objects with the corresponding weights and profits. Okay. So I have used three terminologies: object, weight, and profit. And the object is I, W of I, and P of I. You can observe. Okay. So I told you I ranges from 1 to n. Just list it out like this. So 1, 2, 3. Respective first object weight is 18, 25. So you should remember, see this. First weight is profit is 25, weight is 18. So like this, just list it out. Right? So you can just list it out. One second. One second, students. Okay, so you will have to just list out the items carefully. Commonly made mistakes I have observed, you will mismatch weight and profit. So you should not do that. So carefully, you will have to list out the items. So instead of weight, you will write profit. Instead of profit, you will fill up with weight. So that if you do such mistake, you will lose marks in the beginning itself, right? So carefully list out the items in the form of the table what I have told you, right? Let us give the strategy. What is that first strategy that I applied? is greedy about profit. The strategy name I give is greedy about profit. Since I have to fill the bag with more profit, I will say greedy about profit. What does it mean? That the strategy that I apply is select an object which has got highest profit. So what I'll do is, in order to select the object with the highest profit, I will arrange the objects in descending order of profits. Descending order of profits. So if I go back to the table, you can already see the objects are arranged in the descending order of profits. Okay. But if it is not, you will have to rearrange it. Okay. But it's already arranged. So I will rewrite the same. Object 1 with a profit 25. Descending order means the highest profit comes first. Object 2, 24. 3, 15. Forget about the weight. Based on the profit, you have to arrange. Suppose, for example, if this was 42, so which object you would have written first? Here, students. If the profit of object 2 was 42, you should have written in the table which one first?
Object 2, ma'am.
First. And then object 1. So right now they are in the same order. Let us continue in the same order. Okay. Now again, with this strategy, I'll have to put one more table in order to keep track what is the portion of the item selected. You can see x of I, and what is the weight added to my knapsack, because I have to find summation of these two entities, isn't it? So I should write this table carefully. So very simple. Object, the weight, the profit, x of I, calculating what is the fraction to be selected, then w of I into x of I, what is the portion of weight added, what is the portion of profit obtained, and what is the remaining capacity in my knapsack for the next forthcoming object. Okay. Now initially, at the first stage, when the thief enters the home, all this will be nil, but the capacity will be how much now? 20. Very simple, right? Now, what is the first object that I select now? My strategy is to select having the highest profit. So which object will I select, students? What do I write in the second row? Which object? Which object? Is it the first, second, or the third? Which object? Students. Janvi?
First one, ma'am.
First one. I'll write that. First object, which is weight 80, profit is 25. Now, check. Very simple as it is. So, you are selecting one input at a time and it works in stages. You can observe that. Now, I'll just check. Can I fit this first object into my knapsack? You can observe my knapsack is still having a capacity of 20 and this is of weight how much, ma? 18. Can I put it completely or partially or not? Cannot be selected. What is x of I in my case? What is x of I? X of 1. What is x of 1 for me? Can I put the first object completely or partially?
Partially, ma'am.
Why partially? Weight is, the capacity is 20, weight is 18.
Completely, ma'am.
Completely. You can place it completely without any issues. Right now, this is the first object. No, you can place it. So, x of 1 now becomes 1. I'm placing it completely. Then, what is the weight? So, since x of I is 1, completely I'm placing. So, 18 into 1 is 18. 25 into 1 is 25. Complete profit, complete waste is dumped into my knapsack. Now, what is the remaining capacity for me? I placed a first object. What is the remaining capacity, students? What is it? What should I write here? Out of 20, now I occupied how much? What is the object
18.
weight placed? 18.
18.
So 20 minus 18. What is the remaining now?
2.
2. Okay. I will now go for the next object. And you all know that the next object is 2. You can observe. Now I bring 2 above, 2 with a weight 15 and 24. Profit. You can now observe the capacity remaining in my knapsack is only 2. I can place how many? 2. 2 kgs or 2 units, right? But the second object is having the weight of 15, right? But I cannot place it. Here you can observe, I cannot place it. Can I place the second object completely, students?
No, ma'am.
No. So there is option here for placing partially. So what is a partial count? That means I can take only capacity 2 out of 15. Only 2 units can be taken out of 15. So what is that x of I that I write now? Can anybody guess? What is that x of I that I write? X of I will be what? Here. I need only 2 units out of 15. Not more than that. How do I write? What is x of I?
0.13, ma'am.
Okay. So I think I can easily write it in this way. That is, you do not have to worry much. I need 2 units out of 15. It will be 2 by 15. Okay. 2, whatever is the remaining capacity divided by the weight of the object. Okay, 2 by 15. So since we have partial been selected, now x of I is 2 by 15. That is only 2 units. 2 units of my second object will be placed. Similarly, what profit I will get? 24 into 2 by 15, that is around 3.2. The profit, fraction profit only I will get, right? Next, what is the remaining capacity now in the knapsack? Is the knapsack full? And you can observe that 2 minus 2. So I have now only 0, isn't it? So I have placed 2 units over, right? You can see 18 is placed and similarly 2 is being placed. The weight is now completely taken up by the objects. The remaining capacity is now 0, wherein you can observe that the third object which is there, the left out object, the x of I will be now what, students? It will be 0. You have to complete this. You should not stop here only, right? X of I, because I should tell which objects are selected, which are not selected. So x of I will now become 0. The rest all entities will be nil there. Okay. Now, from the above table, we can observe that what is x1, x2, x3. That is, what are the fractions of the objects being selected? x1 is selected 1, means completely. x2 is selected partially, it is 2 by 15. x3 it is 0, means it is not selected. Similarly, I will calculate the maximum profit. What is the maximum profit? It is nothing but summation of P of I into X of I. So that is 25 into 1, 24 into 2 by 15. Anyways, this is not selected. Let us not bother because it will be 0 only. Not selected means 0. So I get a profit of 28.2. And what is the maximum weight in your knapsack occupied by the objects? So again, it is W of I into X of I. You get it as 20. So 20 is definitely less than or equal to your knapsack capacity, that is M. Yes. So you can see that here the condition is satisfied and I obtained some profit so called as 28.2. But I am not telling you this is optimal because I have other 2 strategies also to be followed. Okay. We'll move on to the next strategy. Keep track of the profits. We'll see which strategy gives me the optimal one. Okay. The next second strategy is about greedy about the weight. Since I want to fill the knapsack such a way that it does not exceed the knapsack capacity, I'll give a strategy greedy about weight. What does it mean? You would select an object which has got least weight. Keep on selecting the objects which has got least weight and dump in the knapsack. So what is the strategy that I apply here is arrange the objects in ascending order of weights. Right? Take the weights, arrange it in ascending order. So if I arrange the same table again, you will have to rewrite and write according to the order of weights. And we observe that I think the third object has got the least weight. So write it first. 10, 15 and 8. So which are all the objects there? Third object, second object and the first object. The corresponding profits you should write. Do not write whatever is in the first table. Correspondingly, you should write the profits and the weights. Okay. Again, repeat the same thing now. Same table. Right. So initially the capacity will be 20. So which object will I select first? One which has got the least weight. Which is that object, ma? What do I write here in the second row? Which object do I select? Quickly tell me the entities here.
Object B, ma'am.
With a capacity with a weight of 10 and the profit 15, can I select third object completely? Yes or no?
Yes, ma'am.
Yes. So x of 3 will be 1. Sorry. X of 3. Remember it is x of 3, not x of 1. Because I is 3 here. Completely. And the remaining capacity is now 10. Which is the next object that I select? As per my table, which is the next least weighted object. What should I write in the third row? Which object? The second object, which has got a weight of 15 and 24. And you can now observe 15, its weight is 15, but remaining capacity is 10. I cannot place it completely, but I can place it fractionally. Can anybody tell me what is this x of 2 now? What is x of 2? How do I write x of 2? What is the formula?
10 by 15,
10
ma'am.
by 15 and 10 by 15 can be written as 2 by 3. Yes, 10 by 15 simplified to 2 by 3. Fine. And you can observe I am calculating the W of I, X of I, that is 10, and the profit, the fraction profit is 16, right? And the remaining capacity is now 0. Nothing is there. I mean, it is filled. The knapsack is filled. Similarly, the next object, listed object is first object, where X of 1 will be 0. I am not selecting it. Okay. From the above table, again, we observe that X1, X2, X3, X1 is not selected, X2 is selected 2/3 of it, and X3 is complete selection. And you can observe the profit obtained, you can observe is 31, right? Previously, it was how much? Previously, greedy about profit, when we went, it was how much? It was 28.2. But you can now see it is 31. Isn't it greater? The profit obtained is slightly greater compared to the strategy applied with respect to profit. Isn't it? And the maximum weight, again, the knapsack is completely filled. No harm. Right. This is second strategy. So we have still one more strategy. What is that strategy? Let's see. The third strategy is greedy about profit per unit weight. What is this profit per unit weight is? What is the profit being obtained per unit weight? That is, I'll have to calculate the ratio about P of I divided by W of I of all the objects. So based on this ratio, right, what is the profit obtained per unit weight? I will be calculating, or I will be selecting the objects. Okay, and the strategy is select an object which has got definitely highest profit by weight ratio. So you have to calculate this now, profit by weight ratio. And as you all know, since I have to select the highest, I will arrange the objects in the descending order of the ratio profit by weight. The descending order I'll write. Okay, so you should be careful. Again, rewrite the table. For every object, calculate profit by unit ratio. So I just calculated this. So 1.38, 1.6, 1.5. Just limit to 2 digits after the decimal point. That's enough. Okay. I have to rearrange this descending in terms of descending order of the ratio. So if I take descending order of the ratio, you can observe that in the above table, second object comes first because it has got highest ratio. The next is the third, next is the first object, right? So you should be very careful here, students. First calculate PI by W of I, then arrange it according to the descending order of profit by unit weight or the ratio PI by W of I, and repeat the same procedure. See, you can see second object is selected first because it has got the highest ratio. Its weight is 15. Am I audible, students? Students, am I audible? Students, am I audible?
Yes, ma'am.
I thought I lost the connection. Someone has to reply. Don't keep silent. Okay. Quickly moving to this. Okay. So similarly, you can observe here. The second object is selected whose weight is 15. I can place it completely, no harm. And henceforth, x of 2 becomes 1. And the remaining capacity is 5. Right? Next, I select the third object because it has got the second highest profit by weight ratio. Its weight is 10. And you can observe, I cannot place it completely. So partially only I can place. Partially in sense 5 by 10. Right? So 5 by 10 is 1 by 2. Simplified. And you calculate W of I and X of W of I into X of I and P of I into X of I. And the remaining capacity is 0. And X of, that is this first object, X of 1 is not selected at all. Okay. Now just observe what happens here. Similarly, from the table, we observe that x1, x2, x3, with respect to x1, it is not selected. x2 is completely selected. x3 is half selected. Portions of the respective objects. And you can also observe that the maximum profit obtained is 24 plus 7.5. It is how much, students? 31.5. You can observe now, earlier it was 28. Greedy about weight was 31. Greedy about profit by weight is 31.5, which is slightly greater, right? So, and the weight is, it is completely filling the knapsack capacity, no worries, right? And with this 3 strategies, the research is already made. Any objects you give with respect to weights and the profits, which will give you the optimal solution. With the example what we saw, which gives you the optimal solution, students? Which will give you the optimal solution? Which will give you the optimal solutions quickly? Which will give you the maximum profit? Which strategy? First, second, or third?
Third, ma'am.
Third one, it is being greedy about profit per unit weight. That is with respect to profit by weight. Ratio of profit by weight always gives you an optimal solution. Sometimes some of the strategies might be giving you the same values, right? But the researchers have found that For all the inputs, the third strategy is the one which gives you the optimal one. But all the strategies are feasible solutions, no doubt. But greedy about profit by unit is a one which gives you the optimal solution. Okay. So we have the assignment for your next class. Okay, this is the assignment and asked in your previous exams too. So carefully solve the problem and keep it in mind, students, when they give you the problem here, you have to apply all the three strategies. All the three. What are the three strategies, students? Greedy about? Greedy about?
Profit, ma'am. Greedy about profit.
Profit weight and profit by weight. That is ratio of profit by weight. Okay. So you should apply all this time. And many a times I have observed again the same thing. Coming out of the exam hall, you will tell, ma'am, I have written everything. But then this will be for say 6 marks most of the time. 6 marks, only one strategy will not hold good. So 3 strategies will be allocated for 2 marks. Are you understanding? So you should give all the 3 strategies. If you give only one strategy, that is profit by weight, you will get only 2 marks. The other 2 will be gone, other 4. Are you understanding? So you should make sure you write all the 3 strategies with appropriate things. And the reason I have given you the tables here is so that you don't make mistakes. It might take 5 minutes extra, but it will avoid making you doing mistakes. Okay. Okay. Thank you, students. We'll end up with the session. I will share the PPT in the Google Classroom. Kindly look into it and solve the problem for the next class. It has to be solved. Who will solve it? You can ping me in the WhatsApp group. Both the problems. Okay. The others also have to solve the same. Okay. Any doubts you can ask me? Otherwise, I myself will ask one or the other question. No doubts. Okay. Can anybody tell me in simpler terms what is knapsack problem? Forget about all mathematics and other things. In general words, what is knapsack problem? Quickly. Srinivas is there for me. I've not heard your voice anytime. Akshita. Akshita, girl or a boy? Okay. Anusha. Ritu. Ritu is there for me. Nobody. Okay, whoever is there, answer now. Anyways, we'll wind up. What is knapsack problem? Someone should have wind up the session now.
Ma'am, we'll have a knapsack with certain capacity. We'll have to add objects to it such that the profit is maximum and weight doesn't exceed the capacity.
And you have to add, there will be n objects wherein every object will have some weight and profit. Yes. Okay. So what are the different strategies that you apply? Someone else? Navya? Navya? Nobody. Sneha? Neha? Sneha? Neha?
Yes, ma'am.
Yes, tell me, Sneha. What are the 3 different strategies?
Greedy about profit
Okay. You select which
and
object
greedy
first?
about it.
In the greedy about profit,
ma'am.
which object will you select first? Greedy in
First one,
greedy.
ma'am.
First one only you will select first. Greedy about profit means which object will you select?
Which has highest weight.
Wait. Profit. Greedy about profit, ma.
Which has highest profit, ma'am.
Profit. The object which has got highest profit you will select first. Okay. Strategy 2.
Greedy about weight, ma'am.
Which one will you select first?
Which has highest weight.
Greedy about weight you will select highest weight.
No, ma'am. And is greedy about weight.
Greedy about weight means which weight? Which object will you select?
Ma'am,
Highest
least
weight?
Least
ma'am.
weight. Which has least weight, ma'am.
Yes, which has got least weight. Okay. And the third strategy
And
is,
greedy about profit per unit.
okay, which one will you select? Which object? Which has
Which
got
has highest profit
the
per
ratio.
weight
Okay,
ratio.
very good, very good. Prakriti, which all
Yes, ma'am.
will give you the feasible solutions?
All the three, ma'am.
Which will give you the optimal?
Profit per unit weight, ma'am.
Okay, very good. Can I select partially
Yes,
in my,
ma'am. No.
yes,
Yes, ma'am. Yes, ma'am.
Prakriti, can I select partially? Can I select partially, Prakriti?
No, ma'am. The weights and all means
No,
the
I'm
profit.
asking. Okay, let me complete my question. Can the
Yes,
objects be selected partially or fraction
yes,
can be
ma'am.
added? Yes, ma.
Yes, ma'am.
Yes. What is that fraction represented in our problem? Which term represents the fraction? There were so
XI,
many
ma'am. XI.
xi. Okay. The xi ranges from where to where? Prakriti, I think you can conclude.
0 to 1, ma'am.
0 to 1. Very good. So if you are selecting the object uh, fractionally, the profit also will be, if I'm selecting any object fractionally, profit also will be fraction or complete you will take.
Partial, ma'am.
How do you calculate that partial fraction?
Ma'am, the remaining capacity of the
No, no,
knapsack
no.
by the
Profit I'm asking. How do you calculate object which is selected partially, its profit? Partial profit, how do you calculate? Anybody can answer?
XI, ma'am. PI into XI.
Pi into xi. That is how you calculate the partial profit. I'm asking. I think Prakriti, you're right. Fraction, how do you select? X of I. X of I will be remaining
yes, ma'am.
capacity of the knapsack divided by the weight of the object.
Uh,
With
yes,
that,
ma'am.
I think we can conclude. Thank you so much, students. Look at the problem. Yes, we can conclude the meeting. Thank you. Navya, recording is